Good day, all. This is Stephen Stewart from Nuix. I'd like to welcome you all to our webinar this afternoon. We've got some exciting things to talk about. We're here to present with our partner Teradata about some really great ways in which you can leverage analytics to accelerate your investigations, eDiscovery, and compliance monitoring. And the real sort of virtue and value is how you can sort of take all of the capabilities and things that you do with Nuix and really extend it with Teradata's complete suite of analytic functionalities. So with me today, we've got sort of some great speakers from Teradata. We've got Matt Mazzarell, data scientist in field applications at Teradata. Matt has really sort of taken the data science and the power of Teradata's platform and is really helping us to drive it into what can be achieved within the broader Nuix platform. He's actually going to do a great demo at the tail end of the session. It really sort of shows how this information can materialize throughout the entire Nuix stack, specifically within web review and analytics. We also have Will Griffith. He's a senior business consultant with basically Teradata's Think Big group, and is really sort of focused around financial services and really how you can kind of go from thinking about solving problems in a sort of a non-concrete sense to really how you can drive it into actually operationalizing it to improve the overall efficiency of the business. So again, this is a great opportunity to really sort of learn about how you can think about altering the shape and scope of what you do with Nuix to really essentially make it smarter. You know, from today's perspective, we're going to sort of run through a little bit about more sort of about Teradata. If you're on this, you sort of know all about Nuix, talk about our joint value proposition, and then really sort of lead into some of the cool things that you can do to really get the juices flowing about the types of things that you can accomplish with this partnership. And so with that, I'll turn it over to Will Griffith.
Thank you, Stephen. Again, this is Will Griffith with Teradata's Think Big Analytics Consulting Organization. And I'm going to take you through a couple slides that give you a little background on Teradata and then talk about our integration with Nuix and some of the value that we and our customers have driven from that. So Teradata as a company has been in business over 30 years. And a key element of our history, our legacy is that even though we're a technology company, we are business outcome led. We are looking to provide value through the use of data and analytics for our customers. And a lot of our customers are some of the largest ones in the world. And we're able to help them impact very significant areas in terms of reducing fraud, increasing customer retention, expanding customer markets, better managing supply chains, doing better predictive maintenance on very complex systems like high-speed trains and not automobiles, but aircraft, commercial aircraft. So across a very broad spectrum of industries, we're able to help our customers really generate outcomes that wouldn't be possible without the extensive use of data and very advanced analytics. As a company, we're divided into three key areas. One is somewhat what we're known for from a legacy perspective, which are our platforms, which include both the databases that house these large, massive volumes of data, but also the actual systems they run on themselves, the iron or the hardware that they run on. That's kind of our legacy, but today we are much more versatile. We have deployments that both go into data centers, but also go into the cloud, and we license different packages of software for different needs. One thing that's unique, though, is all of those packages share the same common data structure. So that's one part of our business. The second is architecture. We are now a leading firm to help organizations bring together diverse analytic architectures that include open source technology and relational technology to solve business problems and achieve those business outcomes. And then lastly, the consulting organization, which helps them actually monetize or figure out how to get economic value from these deployments. And we do that both on the front end in terms of assessing the potential, but also helping them maximize the opportunity or maximize the outcomes through the full life cycle of these solutions. And many of our customers have been customers of Teradata for over 30 plus years. We're a very large company. We have a global footprint of over 70 different countries. We have about 10,000 employees, probably close to 11 or 12, roughly half of which are consultants out in the field. We've gotten all kinds of recognition in terms of our standing in the industry, both in terms of as a technology provider, but also being a really good company to work for, a very ethical company, and one of the leaders in a lot of different areas. So if you don't know Teradata, I urge you to do a little research on us. Our stock symbol is TDC, and overall it's a leading company, kind of the market leader in the data and the analytics space. And as I started with this discussion, we were always business outcome led. And although we have a wide range of customers that we could show all their logos, what we're really psyched about is the ability to show some of the value that some of our customers are able to achieve out of the use of Teradata data and Teradata analytics in their day-to-day organization. I mentioned high-speed trains. Siemens uses Teradata to do predictive maintenance worldwide on all of their high-speed train fleets, which they manage on an ongoing basis for their regional train authority clients. And part of their incentive is on-time arrival. They get basically paid on the availability of their fleet. The availability of their fleet is driven by, to a large degree, their ability to do predictive maintenance, which in turn is driven by data and analytics on a Teradata backend platform. Another example would be Wells Fargo, which uses us in a very wide array of business units and business functions. But a very simple one is they use Teradata to analyze the call paths that people were taking through their voice response units. When you dial in and you initially are listening to the voice prompts, a lot of people would get lost in those or get confused in those. They use Teradata analytics to analyze the path of travel for their customer base through those IVRs, and we're actually able to improve or optimize those paths, increasing not only the efficiency of those call handling systems, but also the customer experience was significantly better in that process. And we have literally hundreds and hundreds of different clients that we can talk about the business outcomes that we've helped them generate. And that's really what drives us in a day-to-day basis for achieving the types of capabilities and outcomes that we want our customers to have. Now, the combination of Teradata and Aster also provides similar business outcomes where there are improvements that can be expected. And this slide has 3 points that I want to emphasize. One is that using analytics on top of or within the Nuix application stack enables a litigator or an investigator or even an internal audit or compliance person to better pinpoint where the problems are, so they can increase their rate of false positives, which is really the middle illustration here. At the same time, and this is an area where a lot of efficiency can be gained, there's a distinct and dramatic improvement in a reduction in the false positives, those signals that would typically generate interest by somebody reviewing activity or reviewing documentation. But after review, they're really not anything to worry about. It's a very common type of correspondence or a common type of document exchange. And that was wasted time for that investigator or that litigator or that audit person. And we've seen cases where we've been able to reduce by almost a factor of 10 the false positives in a work stream by applying analytics to the queuing rules or the queuing mechanism for things coming into an investigator or a auditor's in-basket for review in the Nuix workflow. And all of that leads to not only better customer experience and employee experience, but also reduced costs because you're not wasting time looking at things that are false leads or false positives. And we do that through using analytics to basically take multiple data elements, some of which are generated by the Nuix engine and are turned into metadata. But other data elements include the actual content that we can, in effect, understand through analytics in the message, the content in the message, but also secondary data that may reside on legacy systems, maybe a transaction history or a customer profile or an employee profile. All of those things are definitely available and are a rich source of input into our analytics. And the result is a score that would tell that investigator or that compliance officer, how far up the threshold of risk is this particular document or this particular artifact. And we do that by inserting Aster basically into the Nuix stack. So the ingestion occurs as is commonly done. The investigator or the administrator can go in and look at the documents that have gone through that ingestion process and use the traditional Nuix capabilities, including text search, or they can have those documents have an analytic review and be scored according to the business rules and be presented in a priority order. And then that's being presented within the Nuix user interface. It's something that Matt will show a little later on. And the full functionality of that user interface or the investigation GUI is available for use and handling the eventual outcome of that artifact or that document that triggered the problem initially. And there's a little bit of a build here that basically shows that flow coming from ingestion through applying the basic Nuix capabilities, moving the data into Aster, which is all done automatically, and then scoring the resulting data elements into a coherent fashion according to business rules, and then presenting that back in a prioritized fashion to the investigator or the reviewer. And that type of activity is typically going to be done by an investigator, the current or the typical Nuix user today. But in addition, other people can apply different levels or different levels of capability to this data set. And moving kind of up the spectrum, we would have business analysts. These are people that are not only familiar with Nuix, but would be able to access the Aster, the Teradata Aster App Center, something that Matt will show you, and also use very standard and very common SQL commands to help tune those analytics to achieve even better results in terms of the prioritization of artifacts coming in for scoring. Moving up the spectrum a little bit further, you may have an analytic user, a typical statistician or something like that. Somebody may be familiar with using SAS or R, which are very common tools in that environment. And then even going further, a data scientist can apply more or less the full set of tools, both commercial and open source, to apply really advanced analytics to create even more complex models for that scoring. It's something that a data scientist like Matt would be able to do. We have data scientists within Think Big Analytics that do that as part of a consulting engagement, but also a lot of our customers have those skill sets in-house that today do statistics and modeling and advanced analytics. The point of this slide, though, is to really show that we cover the full range of analytic capabilities in what we're presenting to you today. Easy to use on one end, very complex and capable on the other end. And the types of analytics that we apply that are part of the Teradata Aster Analytics package include SQL, which is really the language of data and data manipulation, very common in business today. It's something that you probably use whether you know it or not. If you use a BI tool like Tableau or MicroStrategy or Business Objects, those are all speaking to data in a SQL format, again, using the language of business and business tools. Also statistics. Some of the capabilities of packages like R and SAS can be delivered directly from those natively, or the Teradata Aster has a suite of statistical tools that numbers, I believe, 30 or 40. Most of the common statistical analytic techniques are covered by those tools inside the package. But if you choose, you can also use something you're more comfortable with, like SAS. Machine learning, which is a form of artificial intelligence that basically can consume large volumes of data and then interpret from that data patterns and clusters of information and really learn from that information where there are anomalies, things that may need to be investigated or reviewed to see whether they are a threat or a risk to the organization. So deep learning can on its own begin to find some of the things that a more sophisticated or advanced data miner would have traditionally done through repetitive and very complex queries. Deep learning is the capability of the actual software to interpret those large data sets and find features in those data sets that require review, something that is also included in the Teradata Aster platform. Path, pattern, and time series. Any investigation heavily relies on understanding the sequence of events leading to some type of transaction that may be fraudulent or criminal, some type of interaction that may be problematic. So kind of understanding the history, understanding the path that was taken to get to a certain point that indicated a problem. We have the analytics built in. It is something that Matt will also show this group, where we can basically stitch together in a timeline to separate data elements that may share some commonality, whether it be a client ID, a transaction ID, maybe a web browser or a cookie through a web interaction. All of these things can basically be stitched together in a time-oriented series or a time sequence to help understand what the predecessor events were and also what the events that followed were. Text analytics, really one of the most important analytic functions in our integration. There's a suite of text analytics capabilities that enable the software to basically interpret the message or the communication or the artifact, and not only infer meaning, but understand sentiment, do classifications and groupings of that against other similar documents. Some very, very sophisticated things that today, for the most part, is being done by paralegals or legal review people or people in the organization that have responsibility to audit things or to confirm compliance. We have the abilities in our text analytics suite to do that in a very automated and highly scalable fashion. And then the last type of analytics that I'll mention is graph analytics, which is looking at relationships between entities and objects and understanding where there are commonality and linkages. This is something that Nuix has some baseline functionality in, but we actually add significantly more analytic functions and capabilities to use graph analytics to look at what are known as edges and nodes, which are the points of interaction between entities or objects. And graph analytics is a very, very powerful tool from an investigation point of view. And what's really unique about the Teradata Aster is not only do we do it at scale, chewing through massive volumes of information, but we can link all of these together into effect an analytic workflow so that it can become, once the routine or the model is determined, where you're using different analytic techniques to achieve a desired result, that can basically be stitched together in a workflow that is then available to the very common business user. If I go back a slide or two, the business user that was on the far left of that slide, it can be stitched together into an easy-to-use app, very much like an app that you would have on your mobile device and you would download for accessing a system or a capability. We have that ability within Teradata Aster to take very complex analytic workflows and encapsulate those into an app available through the App Center, and then can be run by a typical business user who then just drops in the various parameters that they want around that analytic app. It may be a date range, it may be a dollar value range, it could be a variety of things that are parameterized, but it's meant to be made to be very easy to be driven and used by a traditional business user. And we call all that capability multi-genre analytics, and that is something that is very unique to the Teradata Aster platform. I'd like to turn it over to Matt right now to talk about that very important text analytics function in a little bit more detail. So Matt, take it away.
Hey, sorry about that. I think I was on mute. So can everybody hear me?
Yeah.
Just to put my check. Great. So I'm Matt, a data scientist at Teradata, and I just want to clear up a few things about the vernacular and what we're talking about. So we're gonna loop everything into text analytics here. That's probably the most popular method of getting immediate value from your Nuix data, as Nuix rips the text out of any kind of data type. And we can read that, we can process it much like emails or Bloomberg chat and things like that. So text processing and NLP, we're trying to bring structure out of this text. So while Nuix pulls the metadata and the text out, there could be something in the text that we want to structurize or extract out of the text for further analytics. That's definitely something we can do. And then we go to the machine learning aspect of it and applying statistics and time series to text analytics, so we can take pieces of those structured in text and make accurate decisions about, you know, what's the sentiment of this email, or what's the priority of this email, what's the risk of this text communication in my organization for leaking possible, you know, confidential information. So I'm going to loop in all of those text processing categories into text analytics, and go further and talk a little bit more about that. So next slide, Will. And these are just a few of the applications that we have, sentiment being the most popular. How can we take that bag of words that we get in any one communication and associate that with positive, negative, or neutral sentiment? It's really popular in going through like review analysis, where I can pull a lot of Amazon reviews and decide if they're positive, negative, or neutral, and decide what about that is positive, negative, or neutral. What are the drivers? And that would be, I think, very useful for a Nuix investigator to quickly see on every single text or text-based item that they have in their portfolio, what's the relative sentiment of that? What are the negative things? What are the positive things? I think it would really benefit a Nuix user to go at that, especially when you make your very advanced searches. Show me all the negative things that happen towards the end of the month in this one topic, and a topic being something that we can actually classify in our database. Is this email bulk recognition? Is this a bulk email pushed out to the organization, or is this a very tight communication between two entities that might not have been talking before about a money transfer, let's say? So that topic modeling and document clustering is very very popular in our solution, and I'll show some of that in the demo. The text categorization, basically automatically deciding where this text should end up in your queue, or for an organization, you know, trying to determine, you know, malfeasance in their body of communications. What type of malfeasance is this? Is this fraud? Is this something else? Is this possibly just an organizational issue or a mistake by someone that's causing a customer complaint? Those are the kind of text categories that we go after with our text analytics. Also, identity matching. So it's really important. You know, you can unbox someone's like a complete email archive, and you might have 10 different definitions for a single person, for a single person's email. There might be several okay ways to write their email, and it still works. There might be several, you know, misspellings of names and different stuff in the email that references these objects. So connecting those identities to a singular person, that's a function that we do very well, basically looking at string matching and seeing how far they differ. It's really good for creating master data management, a single version of the truth, and to be able to link this artifact with this other artifact because they were both written by the same person. In the data, it might not always appear that way. So that's an example of that. So moving on, Will. And just to show
hey Matt, before you move on, I just wanted to sort of pop in on sort of that prior slide. So for all those sort of on the call, you know, this sort of specialty and sort of range of text analytics, it's really sort of a powerful extension of what you can already do today in Nuix. And sort of the idea being, you know, just as Matt and Will have enumerated, you take sort of the raw text that Nuix provides and you farm it out into the Teradata infrastructure. And then you have all manner of different types of analytics that you can run against and really start to dig into it. And for those that sort of have that data scientist mindset or sort of are looking to do a greater level of analytics, what Teradata does is make this as a really approachable fashion. So sort of, you know, we talk about name disambiguation is sort of another way of describing identity matching. And as you're sort of looking at all of the entities that have been extracted, you know, company names, corporate names, individual names, different names for different objects. Really what they've done is built a model in which you can start to pattern, you know, define those patterns so that it can be reusable and sort of then drive that information back into Nuix to further your investigation. You know, so we broadly think about text analytics as sort of this really sort of open-ended black box with individual elements. What Teradata is providing is really sort of all of the algorithms that are really part of a broader textual analytics suite and allowing you to sort of interact and drive sort of information in and out of the Nuix platform by leveraging their text analytics capabilities. So really, really powerful stuff. And as Will said earlier, sort of the multi-genre aspect of this is the text analytics is just the one element, but you can really start to think about how you could align this with your statistical analysis as well as the graph and pattern. So it's really a fantastic way in which we can move data in and out and really take that next step around delivering value through analytics, and again, sort of really focusing you in on sort of the documents and the information that matter most. So back over to you, Matt. Sorry about that.
Sure, and just to piggyback off that, I think it's really just an effort in trying to save the investigator time, because you might go through your own way of text categorization or name entity recognition or topic modeling, and that might be a very manual process. If we could speed that up and make it so that when you process that data in Nuix, you automatically get these analytics as the end user without having to think about it or drive it on your own. It's just a huge time save. Okay, so the next, I'll talk about the, I guess the evolution of analytics ever since, starting in the 1960s and going into where we are today, and what you can expect, out of capabilities of our platform. I think people coined the term artificial intelligence, back in the early 90s, thinking that we could get creative, we could infuse enough intelligence into this machine such that it could act, autonomously in its own way and do the things that we programmed it to do, and we would call this artificial intelligence. And that theory still exists today. It's still very popular, but what goes under the artificial intelligence and what goes into it is are the next few things that I'm going to talk about. One is machine learning and statistics. This has been around since the beginning of math, really, statistics. But one thing about statistics that you might know if you've ever done anything with it is that it takes a lot of processing power, and you can't really take a lot of shortcuts or approximations when looking at a very big data set. So once we've hit the 2000s and we have a big explosion in available computing and computing power that are on our devices, it became, the business user or the enterprise user then had the ability to run these kind of machine learning, statistical-based algorithms to give you a statistical certainty on an outcome or a statistical certainty on a risk value for any one, piece of information. And then going further, deep learning is a little bit different than statistical learning or machine learning. Deep learning is really building a structure called a neural network that mimics the human brain. So we can, this is the black box approach, but this is the approach that we're learning more and more today. We can push information into the structure that mimics a brain, and it can give us a really, really accurate result. And without so much explainability, but we can get down to accuracy on problems like handwriting recognition and image classification. Those are two problems that you can be assured that Google and other companies use, like the mail service, for recognizing your handwriting when you write down on an envelope. That's being done using deep learning because statistics doesn't necessarily represent handwriting so well. So that's why we're moving into that space of deep learning. And we're assuming that deep learning and machine learning can go into the overall category of artificial intelligence that can help automate these systems and help these systems make intelligent decisions on their own based on what we teach them. So going forward. And then the most important thing, I think, as a data scientist myself, what I can get from an investigator when looking at these fraud use cases inside the thread or anything where an investigator is needed to confirm that this was an actual event, it's pretty easy to determine that, okay, a churn example, somebody left your company, a customer canceled your service, that's pretty obvious. But someone committing fraud, not so obvious, that we definitely need an investigator to investigate on that. So once the investigator has picked up that information, validated that this is in fact fraud, that's a great data point that I can use as a data scientist to make my algorithms and my models better over time. And without that investigator, or without the actual truth that this is fraud or not, I have no idea. I'm simply guessing. So that feedback loop is extremely important. And for the Nuix user, having someone full time that's basically looking to prioritize the items in their investigative queue is going to save them an incredible amount of time, and it's going to help them miss less. If you run analytics on everything, everything that you could possibly be looking for, we'll find more that the investigator might miss because they're a person. But the person is going to have the ability to infer that this is actually a real event, and the computer really doesn't have that ability to infer or statistics. So that's the symbiotic relationship we're working with here and we're promoting. And then of course we have these visualizations. So looking at fraud in the lens of a graph visualization, where you can see that big red cluster down there of people colluding together and talking to each other in a distinct network. That's a visualization capability that can help explain the analytics that we give to you. So you can visually, here are all my users. Oh, there's a huge community of people talking here. That's a point that I can go drill down and figure out more about. And then you'll see some of the pathing visualizations. And that's important because we look at events in sequence that happen together. So what is the path to fraud? Someone opens up an email from a customer, puts this information in, sends it back to the customer, gets something back, does this. Trying to determine what a common pattern would be for fraud is something we can show through those visuals to show the flows of the different things. And then, of course, your hierarchical clustering, putting things in distinct categories where they belong relative to what this item is. This item is like all these other items because of these few features. So wouldn't it be nice if you could find something that you know is interesting and that you know is showing something? Okay, show me everything else that is most similar to that, and then investigate further from there. So next slide. And I think I'll give it back to you, Will.
Thanks, Matt. So I'll talk about some of the integration features that we have between Nuix and the Teradata Astra platform. First of all, Nuix is great at ingesting thousands of different artifacts or objects at a very scalable rate, and being able to extract both metadata and the text from that object. And that is consistent with our integration. We don't impact that at all. We basically rely on that as a means to get in volumes of data into an analytics ready structure. We do add, the Astra though does add the ability to filter out things that are repetitive. As an example, emails have basically history. They have strings of previous communications, and in some cases, parts of that message repeat itself multiple times within a string. Those don't need to be viewed individually. They can be determined to be part of a repetitive string, and they can be filtered or purged so that what is left is the unique object, the unique artifact that needs to be looked at or investigated. So we have the ability to do that sort of filtering. We also have the ability to take out the low risk disclaimers at the end of emails. Those are very repetitive in nature, and we also look for that type of messaging, and then we filter that out. I mentioned earlier that not only can we use the metadata that's extracted and the text object itself for analytic purposes, but we have access to historic data sets, maybe from transaction systems or other internal systems within a corporation, to marry up to the extracted data and combine a much more powerful tool to uncover wrongdoing or uncover threats. The mixing and matching of the analytic techniques that both myself and Stephen mentioned, that multi-genre analytics. And then lastly, the ability to encapsulate these complex workflows into easily used, very accessible app-like applications through our App Center framework. These are a couple of the use cases that we have seen in the field. I'm going to walk through a couple of these individually. There's going to be a lot of information on the next couple slides, but I'll try to categorize it or simplify it for you and then hand off to Matt for the actual demonstration. But one of the use cases that we've worked with is in a very large wealth management firm. They have about 15,000 wealth managers out in the field, and they are obligated to monitor all of their communications between their representatives and their clients. They're mandated by FINRA to monitor those for any wrongdoing. And prior to the deployment of our system, they had about 400 people, both onshore and offshore, low-level people that were basically opening up a percentage of emails and reviewing them. They were only opening up about 50% of all of the emails, and they were reviewing them for wrongdoing. we implemented our system, we were able to significantly reduce that staff by a factor of 10 by eliminating the number of false positives that they were wasting time on. And the resulting things that needed review then were able to be reviewed by those analysts, the remaining analysts, and 100% of those objects were being reviewed. So they're really just investigating the things that had considerable threat or showed some indicator of wrongdoing, becoming very, very efficient, but also becoming much more accurate in the process. And that has driven a lot of value in that particular organization. They've since expanded it into other parts of the organization and are looking at it right now to look at sales practices throughout the financial institution, which would actually dwarf the deployment that was only looking at the wealth manager's communication. So that is an area we call communications compliance. We know the source data, we know the typical challenges, we have an analytic approach or methodology, we talk about some of the integration features, and we have some proven outcomes. So I'm going to roll through these 4 or 5 different use cases, but all of them share a similar framework where we know the problem and we know how to address it. Now, these 4 or 5 use cases are not all of the use cases that are out in the market. We're constantly finding new ones, and we would love to work with your organization if you have a unique challenge. But communications compliance is one of those use cases. Insider threat is another, where this takes various forms. It can be somebody that is trying to exfiltrate confidential information. It may be somebody that is sharing information that should not be shared internally or externally. There's a variety of different categories of insider threat, but we can look at those interactions, we can look at those communications and score it with our analytics to really determine the level of risk, and that then is narrowly focused down into a queue for a reviewer, an auditor, an investigator to look at. The next one is internal fraud detection. This typically has monetary aspects more so than intellectual property, but knowing who is perhaps giving insider information to somebody else who is then trading on it. Our approach here kind of looks at the opportunities that are given to these individuals, the accessibility to information, and some other factors that are used to be combined analytically to help determine both the risk and then as we see artifacts flowing through the organization, to actually measure those risks relative to the personalities and the personas that are taking part. Information governance, understanding where personally identifiable information may exist within the organization. More so than just doing simple text search, we can use analytics to find, as discussed earlier, entities that may have some variations in spelling or nomenclature and determine that they're all an individual entity, and then go out and look at all document artifacts within the organization that use any number of those different variations, and then gather in where the personally identifiable information may be residing on the network to determine the level of risk. This is an area that a lot of multinational corporations are now faced with due to the new regulations that are being mandated from Europe. And then, of course, the traditional, or one of the most traditional Nuix use cases is eDiscovery. And I like to really term this as eDiscovery on steroids, or eDiscovery that is turbocharged. We basically add analytics to the process and make it A, more efficient, and B, more accurate. So with that, I'd actually like to turn it over to Matt for our demonstration. And Matt, you can take it away.
So here is an example of a Nuix dashboard in WebReview. We've integrated our analytics into this WebReview framework, and as the end user can look at the dashboard, they start to see things that might not necessarily pop up, on their traditional Nuix analytics. And these are these categories that we're defining using that text categorization functionality that I was describing to you before. We're basically looking at all the Enron emails and assuming that there is some financial context in this. And we're trying to figure out all the possible evidence of malfeasance or fraud, or really anything that wouldn't be compliant that happens in all these emails. So we have fraud, we have money laundering, the broker error, insider threat, different things that represent items that we have to report when we see this across communication. And this communication text categorization was built on our communication compliance use case for financial advisors and their clients. So we're looking, we're placing this Enron email data set as a demo data into that world of compliance with financial advisors and checking against all the things that they can and cannot say in those emails. So here, for an end user, we might say, okay, well, I see, my positive, negative, and neutral sentiment. I have my text categories. I'll probably go look at my, let's say customer complaints, the customer complaints that come out of conversation with my employees and my financial advisors. So clicking on that will drill down to the individual emails. Wait for that to repopulate. And interestingly enough, there is some overlap. We do see some emails that trip over different categories, which is interesting. And also see that we have much more negative sentiment than we did, looking at an overall view, which was, I thought, pretty interesting. So going from here, we can go down to the grid view and start to look at some of the things that pop up on our queue. And the first one that comes up is cooperation with the FBI, which I thought was pretty interesting. Basically, they were saying, we encourage employees to cooperate with the FBI because there's been allegations of destroying of documents that have happened at Enron. In this case, we all know what happened. And there were text, encapsulated inside this email that triggered us to say you probably should look at this because this might be an issue. And of course, this is obvious in the Enron sense, but if you were looking at this just from, without any bias or any knowledge of what happened, this is immediately interesting. I'm glad I found this. And we can look at the metadata and see, all the things that go with the metadata of this email. So the key word here, contact attorney, because these words were close to each other, we decided that was what flagged this email. And we put this to the top of the queue. We can also look at the text analytics full, and you can actually look at some of the negative sentiment words that went into this, because there was allegations and destruction. Someone said like, so that was positive, but overall a negative sentiment score. Okay, so and then just to go to one more, just to show another example. This is Virginia Power, Energy, and Marketing. Is it the first one to raise this issue? Someone asked, and it looks like Sarah Shackleton says, we received a written response from CP claiming that it has no payment obligations because of our bankruptcy. So the fact that, we have no payment obligations, something could go unpaid, this is an operational issue, could be something very interesting for an investigator to pass this one level up and escalate this email as we see that there is obviously a problem going on. So that's the conclusion of my demo. Or actually, forgot to mention the tags. These tags are what helps us collect that ground truth or collect the feedback from the investigator. If we were to triage this and say this needs further review, then this is going to go to someone else for further review, obviously, and it's going to go back into our system to make sure that we know we're going to pick up anything like this if we ever see it again.
Hey, Matt, this is Steven. Before you sort of conclude, can you sort of, in case we've got some real tech folks on the call, can you sort of run us through, not in great detail, but sort of essentially the analytics package that you ran against this? Because I know that you've done things about sort of email address disambiguation. I'm pretty sure you did like text cleansing to get rid of all of the garbage. And so you really put this data through in an automated fashion through a complete analytics package to get these back. Because to this audience, they may look at this and be like, oh, okay, I could just do that with a simple search and tagging routine and sort of get a similar output. But I know that you guys have applied a lot more intelligence to sort of how you've broken down these emails, and it's really sort of that full text analytics process that's happening externally that's really then driving the results back into Nuix that just say, hey, look at this first.
Mm-hmm. Yeah, what we've done is we basically extracted all that text out of the email and extracted all the sender and receiver information. So that text disambiguation that you were talking about, one thing that we did, coming out of Nuix, we saw a lot of different email addresses and different spellings and different abbreviations and different things. So there was an exercise of basically, figuring out who Sarah Shackleton really was across all of her identities. And we did that using entity matching. And that helps us put together an overall score, not just looking at individual emails and how does Sarah Shackleton look in the overall sense about if she's compliant or if she's a bad actor or not. So that was the first step up front to recognize that this is Sarah Shackleton. And then we ran the analytics specifically on this text. So what came in the actual body of the email? We know that all of this is not the email that was actually being sent. This was just what came in the chain. This was an echo. So this was part of another email. So we made sure to wipe this out of our analysis. It's still there for the user to see, but that's not going into our analytics technique. So there were, a few, and this could be disclaimers. This signature down here, we look for that too, where we see a name and we see addresses and things like that. Knowing not to pick up on that because a disclaimer might have lots of legal language in it. And that was a big point of false positives for this big bank that we were working with. So that was part of the upfront work that went into, cleansing this email, cleansing who this person was, who said it, who they're saying it to. Also, removing spam is incredibly important because that makes up about 50 to 60% of your email. Just daily digest of different things coming from Bloomberg, spam from all kinds of different sources. If we did an analysis to say that if you have received, or if you've received like over 20 messages from the sender, but you haven't replied back, we could assume that communication line to be spam, and we're not going to run our analytics over it. So, and that was another part of the cleansing and part of the analytics that really helped us ratchet down these false positives.
Yeah, that's great, Matt. And that's really sort of exactly what I wanted you to highlight is really just, and I think that one more element that I would sort of add to your story is that once you've sort of set up an analytic workflow, it's repeatable. So this isn't necessarily like a one-off type of operation. So these types of data cleansing exercises, they become reusable. So when you think about sort of building this into your overall workflow, I mean, just to Will hit it sort of early on in that, Nuix extracts all the text and metadata. We then pass the text and metadata out into Aster, where Aster then sort of runs this analytics workflow across it and then basically feeds back in data. And so the data that comes back into Nuix is obviously, as you're seeing here, it's tags, or you could use things like custom metadata or various other fields. But the whole idea is it's really allowing you to further inform and, most importantly, accelerate any of your investigations or eDiscovery or sort of any of your workflows by allowing you to hit it with sort of this full battery of multi-genre analytics to essentially point you towards that smoking gun. So again, really cool and powerful stuff. I guess Matt or Will, we've come to the top of the hour. Did you guys have anything else that you wanted to show or add? It looks like you're popping in to sort of show what the repeatability aspect might look like.
Well, I think just a quick little blurb about our product. So right now you're looking at our product, our App Center, and the workflow that I showed you that went into Nuix could be executed by going into one of these apps, clicking on it, and then getting a result. And just one example of one of those apps would be the graph analysis, where you can come in and make sure you run your analytics in the appropriate way, and then get your results. So, outside of what you're going to do in the Nuix environment, if you wanted to execute these workflows and get your own answer, alter them, change things, and re-execute, this is the environment in which you would do that. And we do have some very cool visuals like this graph visual. We were looking at Sarah Shackleton's email before. Now we can click on her and see who she's connected to, and look at her page rank, which is her importance in the overall graph. An example of graph analytics. But yeah, not to go too deep, but yeah, these are different apps that we've created that drive these workflows that go over to Nuix and extend these analysis. And just one thing, the insider threat stuff is really easily highlighted here. We can determine what an anomalous session is. So a user goes through a lot of behavior, and this behavior could be logging into a web page, responding to an email, logging off, requesting access to a system, logging into the system. We see what's normal, in the red, and like this person did this 15 times, they did this, that's all okay. But what about, down below where we're uploading a large file, we're connecting to a DB server over and over again, and these might be individual incidences in Nuix. We're going to group those all together, and then we're going to say that this session is bad. And that's something that we can do within our system to get back to the Nuix user and say, this person is anomalous, check out all their activity, not just the individual bytes and pieces that come across. And with that, I'll hand it back to you.
Yeah, Matt, thank you. I mean, that's great. And I think it really sort of ends on sort of what is a really powerful way of thinking about how these two applications and these two products can be used together to really sort of accelerate your investigation. And it's not just one or the other. It's not just the data exists in, within the Nuix stack and you interact with it with web review and analytics. And it's also not just really sort of the Teradata stack. And again, sort of where the real strength of this partnership started is around thinking about being able to broadly extend analytics across all aspects of your data. Nuix, oftentimes we're dealing with sort of one very specific use case around different types of information. But if you're in the information governance field, or you're in the cybersecurity field, or you've got these different analytics needs, the ability to partner Nuix's ability to extract text and metadata from all manner of unstructured information, and then really sort of send it across the board into a full analytics suite to help you really understand what's most important, gives you a powerful collection of technologies to really focus on almost any of your both investigative or analytics needs. And so with that, I think we're going to wrap up probably 6 minutes early. I would like to call your attention to the names on the screen. So Marilyn Shepard on the Nuix side and Todd Heath on the Teradata side. These are basically the field-facing side for if you have any more questions or would like to engage, you can obviously always then sort of get connected with both Will, Matt, and myself. So with that, I'd like to thank everyone for their time and attention. I would like to thank Will and Matt for their time for presenting this great stuff today, as well as to our organizers and to all those attending. So thank you very much, and everyone have a great afternoon.